Do you guys sometimes imagine how forests in Europe would have looked like, sometime previously? Because I do quite often, in fact. I always wonder how the Caledonian forest from the Tales of King Arthur would have looked like, or how the ancient Mediterranean forest was before the Roman Empire, or even if how the Finnish forest would have looked like before the clear-cut systems were introduced in the 1950s. And as I do wonder how the forest would have looked like before, I also wonder how the forest will look like in the future. And I'm getting more and more worried because I'm a bit afraid that we might not have the type of forest in the future as we do today. And can the kids then even imagine what forests look like? So when I started my PhD in June 2018, I was still in Germany, and Germany was hot, like very much like today, I assume. I remember sweating while sitting down in the office, having difficulty sleeping because it was so hot, and also the endless consumption of ice cream because I needed to have some way to cool myself down. But I also remember that there was a lot of worrying stuff on the news. How we were constantly breaking some, heat records, how there were fires in not only in Mediterranean, but also in Germany, where we were not used to having fires before. And also the bark beetle outbreaks that then came as a result of the unprecedented drought that we saw. And it was like with this new, it was becoming quite clear that we need to somehow do something to change the way we behave and change the way we manage forests to somehow be able to adapt to the current changes in climate, yet alone to the future changes in climate. So we needed to find ways, or we need to find ways, how to make forests more resilient. And we needed to do it now. So I started to tackle this problem with great enthusiasm because I was on my way to save the world, as all of us are in the beginning of the PhD. But I very quickly ran into some problems. First one being that to increase resilience, we needed to know what it is. And there were very many confusing and differentiating meanings of resilient in the literature. And the second one was that because of the so many different meanings, there was actually no commonly agreed metrics to measure resilience. So I wondered, how could forest management be changed if we did not know exactly what we needed to improve? So what would we need to, change in forest management to improve this thing? Or if we did know what we were supposed to improve, we had no idea how to measure and therefore monitor it. And as I'm a person who is slightly obsessed with organization and putting things in the boxes, this type of conceptual unclarity was simply a horror for me. And I was also contemplating on completely changing disciplines to mathematics or something for the clear definitions. But I'm also quite stubborn, so I decided not to give up and instead start to create some sort of order into this chaos. And to start solving these two problems, I identified three questions to be answered. First one being, how is resilience used in the current scientific literature? Second one being, how can forest resilience to disturbances be enhanced? And third one, how does forest management need to be improved to address the climate change-induced challenges? In the forest, kind of literature close to forest, there are three commonly used definitions of resilience. The first one being engineering resilience, which refers to the time that it takes for a forest to recover after disturbance. The second one is the ecological resilience, which is the capacity to absorb disturbance and adapt. And the third one is the socio-ecological resilience, which refers to the capacity of a social ecological system to absorb disturbance and adapt and transform into a more resilient system. To answer my first research question, I investigated how these three resilience concepts were used in the literature, how they were measured, and also what were the similarities and differences between them, as well as how their use had evolved in the last 20 years or so. And I did this by conducting a systematic literature review that started with quite many abstracts. I think there were a couple thousands of abstracts. I also read a few hundred papers. And then the final set that was involved in the interview was 255 papers. Out of these 255 papers, I analyzed what type of systems they were studying, what type of disturbance these articles were addressing, as well as how were they measuring resilience and what type of indicators did they use. And while I was doing this analysis, I could see that there was a pattern emerging, that actually these three resilience concepts were not so much contradictory, but rather they formed this type of hierarchical structure, as you can see in the picture, where the engineering resilience is kind of a part of ecological resilience, because to absorb disturbance, you need to recover from it. And ecological resilience was part of social ecological resilience, because forest is a part of the bigger, wider socio-ecological system that we all live in. And it depended more on the type of question you had and the type of system you were analyzing, which resilience concept to choose, rather than, okay, I need to agonize over which is the correct one. So it's more this resilience of what to what, as was already explained by Carpenter and all in 2001. And I was quite ecstatic to kind of find this structure, because me wanting to put things into boxes is, having structure is a good thing. But there was still the problem that how to measure resilience. I hadn't done anything to solve that yet. The literature review had shown that there was quite many different ways to measure resilience, especially engineering resilience. But I wondered, in this time when forests are facing climate change, biodiversity loss, and there is a market volatility, just to name a few, the time that it takes for a system to recover from a disturbance just didn't seem like it would be enough anymore. So I started to look into how this socio-ecological resilience, which kind of encompasses both the ecological system as well as the society around it, how this concept could be measured and assessed. So I hope you enjoy the picture on the beach. But anyone who knows anything about forest management is aware that there can be quite many different trade-offs between different ecosystem services and between the different uses of forest. It's quite obvious that one cannot maximize both the production of timber to get the most timber out of the forest, as well as maximizing the carbon sequestration or the carbon storage of the forest. It's not possible to do them at the same time. So these trade-offs need to be somehow balanced. Similarly, in socio-ecological resilience, there are these type of trade-offs. For example, if one wants to increase social resilience of the forest owner by carefully using all parts of the wood to bring in more revenue with timber products, with biofuels. But at the same time, you'd actually take all the nutrients out of the forest, because you take everything of the wood out of the forest. So you actually decrease ecological resilience. So you increase social resilience, but decrease ecological resilience. And this doesn't work in the long run. So we wanted to create this sort of framework where this problem of trade-offs and how to balance them was explicitly addressed. And by we, I mean several colleagues who are also in Resonate. We work together to create this type of framework. So we created this framework with several principles, criteria, and indicators, where the need to balance was addressed in the context of forest management. And we created a procedure how this framework could work or would be applied. And we also hypothesized how the results of the framework would change with different forest management goals. The key message we found was that forest management resulting in the highest socio-ecological resilience depends actually quite heavily on the forest management goal, as achievement of the goal could be considered as an important part of resilience. Of course, there might be some goals that are not achievable at all. For example, trying to grow a very productive forest in these heavily contaminated sites, as we just saw. So there is some caveats to this, but I would imagine that quite often forest managers and forest owners have at least an idea what would be realistic in their existing conditions. So the main point is that the management steps to increase resilience to, for example, an owner that values timber production above all, or an owner that values recreation above all. So these steps are not the same. So you are saying that resilience is subjective and there is no universal truth to it. You might be wondering right now. And I would say that to a certain extent, yes, because it depends so much on the goal. But at the same time, forests are still forests, and there are some universal truths or general kind of rules of thumb that do apply. For example, the diversity of species and structures enables several different possible responses to different disturbances. While at the same time, if you have different revenue flows from not only timber, but perhaps also from recreation or other forest-based products, you are not necessarily faced with such a big calamity or financial loss in case there is a big disturbance. So the question is more about what are the optimal values for different indicators measuring resilience to achieve the highest possible level of socio-ecological resilience for a certain management goal. So now I had a framework. I kind of had an idea how to put it into practice in the forest management, but I still hadn't really measured anything because the indicators in that framework were kind of theoretical still. So we hadn't tested them in the field. And it was clear that to assess the socio-ecological resilience, one actually needs to measure many different type of indicators. And for that, I didn't simply have the time to do in my PhD or resources at that. And at the same time, during these 4 years, we have seen that the hot and dry years keep following one another. And more and more forests were dying because of the drought or kind of other disturbances, but very often drought being the first factor to weaken the trees. So I decided that, okay, this is a serious time, so we need to be a bit more focused. And I decided to study how trees are influenced by drought in these repeating hot years. And I did this by analyzing how trees respond to repeating dry periods. And this analysis was done from the dendrometer measurement data. And in the picture, you can see what a dendrometer is. It's an equipment that measures the tree diameter change in short intervals. And they are relatively cheap and easy to use tools, which would make them kind of ideal to be used in monitoring of resilience. And from the dendrometer data, we can extract the measure of tree water deficit, which is basically kind of the measure of tree stem water storage, or it reflects that. So the higher tree water deficit you have, the less water you have in the tree stem, indicating that the higher stress the tree is experiencing. So it's therefore quite good indicator to follow or to look at tree stress. And I was very lucky to be able to use an extensive database on dendrometer measurements from all across Europe. And together with some colleagues, we looked at how long the tree water deficit periods were and how they were related to weather and, for example, the wood anatomy type of a tree. So, for example, coniferous wood type or diffuse porous wood type or ring porous wood type. And we found out that the length of these tree water deficit periods clearly increased with the number of their occurrence for both coniferous and ring porous trees. So it meant that with more periods, the length increased and the trees were not able to fulfill their stem water storages in between those times, which meant that they were losing their resilience to some extent. And so this was exciting because it could tell then that, okay, this is a way that we can actually monitor in the long term tree stress. With the current analysis of the dendrometer data, it's a bit too heavy in the processing side, so it's not very useful yet to be applied in kind of operational forest management. But perhaps with more research, it can become really a quite nice tool, kind of like a pulse meter for the forest. Okay, I think I'm running a bit over time. Oops, sorry. But I'm almost there. So now I had a framework and I had experienced or explored at least one way to measure resilience. But it was still kind of clear that there were some issues in putting the science to practice. I was quite positive from all the science I had read to get to this point that there actually is a lot of knowledge already on how forests can be managed to make them more resilient, but somehow it's not directly applied in practice yet. So there is this gap in putting science to practice. So to answer this question on how much of the research was actually going into forest management, I explored what are the forest management measures to increase resilience to disturbances studied by researchers, and also what are the measures to increase resilience to disturbances suggested by the forest experts whom some of my colleagues had interviewed before. And to understand why the research is not necessarily going into forest management practices, I also interviewed some people who are responsible for developing forest management guidelines in different European countries. And what surprised me as the result of these literature reviews and these interviews was that there is quite clear difference on one hand, what are the forest management measures studied by the researchers, and on the other hand, what are the forest management measures suggested by the forest experts. So there was quite clear divide, and it also indicated that perhaps some of the forest management measures suggested by the forest experts don't necessarily have a very high evidence base behind them. So seeing this, I was also curious to see, okay, so it's obvious that the information from science is not going into practice. And I was curious to see what could be the possible barriers that are hindering this transfer of knowledge. And this I did by interviewing the people developing forest management guidelines. And quite several different barriers were identified. For example, the lack of resources, the lack of money. But one I think was particularly interesting for researchers was the lack of useful and applicable knowledge. So actually, a lot of the forest management experts are bombarded with information, so they are really overwhelmed. But they don't see how this and that scientific research results is necessarily related to their own condition and where how could they apply it. So this was indeed quite a big of a problem. They would need much more local and concrete approaches to change forest management. Okay, now that my PhD is coming to an end, how would I summarize my PhD research? Can resilience to forest disturbances be influenced by forest management? And to answer these questions, absolutely yes. There is quite a lot of things that one can do to increase resilience. For example, just by increasing species diversity and connecting different forest landscape patches together to make sure that the recovery after a disturbance is facilitated. And this is just to name a few examples. And how do we need to improve forest management? Well, I think especially from the last chapter of my PhD, an important factor is to really engage in transdisciplinary research to really address and involve decision makers and forest managers from early on to really understand what are their knowledge needs and how can we as a research community to address them to really provide the best possible, the most informed forest management in the future. And I personally think that's the only way to make sure that we are somehow changing the status quo of forest management today. And coming back to my first question on if you ever imagine on how forests would have looked like, you might wonder if I really do think that forests will not exist in the future anymore. I do not. I do think that forests will exist. They are inherently quite resilient. And of course, a lot of different ecological calamities have happened before, and we still have forests. But I do think that they might be less diverse, a bit more boring, and also harder to find, and only to be accessed in very remote areas. So I think that's why we need to really pay a lot of attention on how we can currently improve our forest management so that the kids in the future don't need to, imagine so hard what the forest looked like today. Thank you.